Welcome to this SIQ Advanced tutorial where I'll briefly explain how the various options given in SIQ might help you to analyze your data. So sometimes what we notice is that you only want to analyze a subset of your data, and you can do that using this option. So here it's set at 0, means analyze all the reads you can get from all the different files. But you can, for example, also set it to 100,000 reads, and then it will limit the amount of reads it will analyze to 100,000. For testing purposes, this might be handy. However, if you really want to have all the results, which is normal, you would just set it at 0. So the minus support, this is the minimum number of reads that have to be present supporting one single event in order to it to be part of the Excel output. So if we find a very infrequent event, one read that supports a certain event, we will discard it because we want it to only be output if we see it in 2 independent reads. And this ensures that reads which are very likely the result of sequencing errors are not included in the final output. You can of course set it higher as you prefer. We find that 2 is fine. You can do it up to 5 without altering the repair profiles in a dramatic manner, unless you have very little reads. So this is something you have to take into account. Then there's the max base error, and that determines how much of the read or how many bases of the reads are actually included. So if there are bases included in a read that have a higher base error than 0.08, the whole read will likely be discarded. If and this we found that for NovaSeq approaches, which we've been using now for sequencing, we find this 0.08 to work very well. But you're of course welcome to play with this. You can set it higher, you can set it lower, depending on your wishes. If you set it lower, the chances are that you're including more sequencing errors, but you might get more rich repair profile. Whether or not that is a good idea, we usually, as a rule of thumb, say that if you do a few replicates, you will see whether or not such events are worth chasing, or if you see a genetic dependency. So you can play around with it, but the standard settings seem to work quite well. Then if you're using SIQ to analyze many samples, then it's a good idea to maybe not use all the CPUs at the same time. So I've been using regularly 12 CPUs at the same time. It works fine, but at the same time I cannot do much else because SIQ is really making it hard for the computer to do anything else besides that. You can set that lower as you wish. If you have only a few samples, let's say one sample, then it will not use 12 CPUs, and you can just use you can leave it as it is because it will never use these 12. Then there's a final complicated option which actually instructs SIQ how to deal with deletion insertions. So we know that some insertions are actually copied from the nearby flank, and this we call a templated insert. We have found previously that these type of events are dependent on polymerase theta or POLQ, but in order to find them, we limit the search space around the deletion. So 100 means it looks 100 bases to the left side of the deletion and to the right side of the deletion, both in forward and reverse complement orientation, but also within the deletion. And the higher you set this number, the more difficult it is it is more unlikely that you will find with high probability a sequence that is exactly the same as the insert, because if you increase the search distance, the likelihood of finding a match becomes larger, but those things will be rejected by SIQ because it will compare the found location of the insert compared to random sequences. And then if you increase the search space, the likelihood of finding a larger match increases. So smaller is better, but if you make it too small, it will also miss templated inserts. So we've chosen now for 100, which seems to work well, but if you are in doubt, you can of course always change this number. If you have not understood what it actually means, this thin search distance, then maybe you can take a good look at our paper that we've published on how to detect these templated inserts. Otherwise, if you don't care too much about templated inserts, you can just leave this setting as it is, because it works for it quite well as it is. Okay, this concludes this tutorial where we have discussed now all the options available to SIQ. If you have any questions or comments, please leave them either here in the on GitHub, or you can leave them in the YouTube channel.